Okay, so this is our second question in phase 143, and we are still treating vectors. Okay, alright, now this is a very pretty question, and let's try and find a solution to it. So the question is very simple, and it reads this way: determine the value of x such that vector b will be perpendicular to vector a, given that a is equal to 5I hat minus 2j hat minus xk hat. So we want the value of x, okay? Then b is equal to 6I hat minus 11j hat plus 13k hat. Alright, so the only condition that will make this problem very simple for us is to visit scalar dot product again, okay? So with scalar dot product, we know that anytime we want to compute the vector A dot the vector B, okay, it is defined as the magnitude of A, magnitude of B, cosine of the angle between A and B. Okay, so cosine of, let's say, theta. Alright, so this is the definition for the scalar dot product. Now we are told that we want the value of x such that B will be perpendicular to A. Now if B is going to be perpendicular to A, then it means that the angle between B and A is equal to 90 degrees. So using this definition for scalar dot product, we can say that the vector A dot the vector B should be equal to magnitude of A, magnitude of B, cosine of 90 degrees. Okay. Alright, now cosine of 90 degrees, you all know that it is equal to 0. So it means that all the term over here goes to 0. So we simply have that the vector A dot B should be equal to 0. Alright, so it becomes very simple. Alright, so now let's compute A dot B. So this is going to be 5I hat minus 2j hat minus xk hat dot, so 6I hat minus 11j hat plus 13k hat. Okay, and this should be equal to 0. Alright, so how do we do this? So in scalar dot product, we multiply the components. So we are going to have 5 multiplying 6, then we have I hat dot I hat, then plus, into bracket, we have minus 2 times minus 11, then we have j hat dot j hat, then plus, in bracket, we have minus x multiplying 13, then we have k hat dot k hat, and this should be equal to 0. Okay. All right. Now we know that I hat dot I hat is equal to j hat dot j hat equal to k hat dot k hat equal to 1. The reason is because these I, j, and k are unit vectors, okay, showing us the direction of x, y, and z respectively. So now, because they are unit vectors, we know that unit vectors have a magnitude of 1. So now, anytime we compute I hat dot I hat, it is the same as the magnitude. So magnitude of I hat is 1 times magnitude of I hat 1, then cosine of the angle between them. Now I hat, they're in the same direction. So the angle between them is 0. Sorry, is 0. Okay, and know that cosine of 0 is equal to 1. So everything here reduces to 1. So I hat dot I hat is equal to 1. The same for j hat dot j hat and k hat for k hat. Alright, so now you are going to have, so these terms over here are going to vanish. I hat dot I hat is 1, so it will vanish. This will also vanish. And the k will also vanish. So you are left with 5 multiplying 6. That will be 30. So 30 plus negative 2 times negative 11. That will be 22. Then you are having over here, you are having minus x multiplying 13. That will be minus 13x. and this should be equal to 0. Okay, so now we have 30 plus 22. This is equal to 52 minus 13x equals 0. So if you transpose the 52 to the other side, we are going to have 13x is equal to 52. Okay, then we divide both sides by, hey, wait, is it 13? Alright, so we divide both sides by 13. So x cancel, 13 will cancel 13, then x is just equal to 52 divided by 13. And I think this should be equal to 4.